Okay, so let's start the lab of the DHCP, and that will be by using my computer. Actually, this one computer will not be enough to prove all of that, so let's do our best and let's connect like 4 computers this way in order. So we computer number 1 0 1 2 1 3. So all of you guys will be connected to a first switch, which is this one, and that will be just like we talked about, the main building, the headquarters, and the far away main router that contains a DHCP server, and this guy, this rogue attacker, as this man in the middle, came in. So for connectivity it will be this way. Okay, so everything is clear now. There is no specific IP addresses that we will use for computers because they just operated in the morning and they will request a DHCP package. Okay, so the DHCP is the responsible one. So the main one will be advertising 192.168.1.0/24. This is the main and correct IP address that all of the devices should receive in my company. And this guy will offer 10.0.0.0/8 class A IP address. Okay, so there will be no config on these switches, there will be no config on those guys at all. There will be only some DHCP server offering from this one and another one offering from this other guy, this man in the middle. Both of them will offer DHCP packages, with the only thing that I will configure myself as an engineer responsible for building A, which is the building or the department that I work in, okay, or this because I'm an IT or a network engineer there, so that I will configure only the DHCP snooping on this interface. But before configuring the DHCP snooping, let's see the default behavior if the two of them did advertise the packet or the offer at the same time. What will happen to those 4? So for this guy, the first one, we'll go to the CLI. Let's do it this way and go up. Okay, so enable. Oh god, oh god. Yes, so enable configure terminal host name. This will be the core router. Okay, so we can identify it. This one. What will happen is that this is fast Ethernet 00, so interface fast Ethernet 00. It will have our gateway IP address, so it will be 192.168.1.1 and /24 with no shutdown. This is just an initial config and that's it. This is the only initial config that I will need for this router. After this initial config, what I will do is that I will configure DHCP. So IP DHCP pool, if you remember DHCP config, please, I hope you do, just in case you don't, because it's the first time we study DHCP in chapter 4. It's okay, we will review it here again, the same steps. I will not skip any step. First, I will create a pool of addresses, and this pool will be called the core pool. Okay, this is number 1. We have entered the hierarchy of DHCP-config. The subnet or the network will be, what was it? Network will be 192.168.1.0 and it will be /24. The advertising default gateway, and it's a default gateway, not an IP. Default gateway is a default router, will be the IP of the interface. And another thing that we need, there is a pool that's offering IP address. Get a DNS. Are we losing anything? No. Make it the Cloudflare DNS, the new one from Google, and that's it. Okay, so that's enough. but just let's exclude the IP address for any conflict that might happen. IP DHCP excluded address. Please don't offer the 192.168.1.1 to any computer because it's already used on the router. And that's it. The end. Okay, so this is all what I need to do on this router. I will not enable DHCP for the PCs. Watch out. They are still static. Leave them. Let's operate this one and make it start giving the offers, and let's see what will happen after that. Okay, no. Enable config terminal. The host name will be the man in the middle or the rogue. He's saying that I'm a rogue. Okay, anyway. So IP DHCP pool. No, I'm sorry. First, the interface, the initial config, which is that fast Ethernet 00 or fast? Why the 5? The 5 is here. Oh, yes, it's the 00. Okay, so 00. IP address should be 10.0.0.1 and /8. No shutdown. You see, he's using a /8, like he's giving more than 16 million. Okay, let's see what will happen. No problem. Exit. IP DHCP pool. This will be come to me. He's an evil guy. Okay, the network will be 10.0.0.0/8. The default gateway will be 10.0.0.1. The DNS server will be like 8.8.8.8, and the excluded address, just like he cares about an excluded address, all what he wants is making like chaos. But anyway, IP DHCP excluded address will be 10.0.0.1. I'm done. You are done. Let's see what first happens for the big disaster. This is the correct one. This is the other one. Let's see the percentage, how many of these 4 will acquire from this one and how many will acquire from this one. So cross fingers, let's see. Oh god, this is the 10. You see the result, it's 10. Okay, the first guy got in the trap. The second one, DHCP. Oh god, no. The second one fell in the trap, fails, whatever it was, the past verb for the fall. The third one fell in the trap. Okay, and the last guy, will we have faith enough? Yes. Okay, so you can see that 3 out of 4 did receive the rogue packet, from this guy. So we have lost 70% of our network devices. Okay, 70%. Can you imagine that? So this is a disaster because 25 only are taking from the correct gateway or are joining our network in the correct way. The others are just giving free information for the attacker. So let's do our best and let's protect ourselves from the switch using this switch. Okay, so enable configure terminal. The host name will be the department switch. What I will do is that I will enable IP DHCP snooping all around the globe. That's it. I've killed everyone. All of those right now are untrusted. All the 6 interfaces right now used on this switch, those 4, 5th and 6th, all of them are right now untrusted. So IP DHCP snooping is enabled, and the IP DHCP snooping should be enabled on a specific VLAN. By default, all the interfaces are under VLAN 1. So VLAN 1, that's good. Exit. Let's go and trust this specific interface, and that will be, we have agreed on which interface will be trusted. Only this one will be allowed to pass the broadcast message up to the core router. The others will not be allowed. So interface fast Ethernet 06 IP DHCP snooping trust. Done. Yes, I'm done, and I hope that I'm correct and that I am done right now. So let's request again DHCP and let's see how many of them will follow the correct one. So let's see now. Oh, what's that? There is an APIPA in here. We have a big problem. We cannot reach the main server. Why? Okay, so we will do some troubleshooting. You can't reach the one. You also. Says the request failed and no one is able to go. It's okay, we'll do some troubleshooting. We have time. Okay. So, and even this guy that did reach the correct one before, it's still saying failed. So what I have lost right now, have I forgot anything? Have I forgot anything? Have I forgot anything? No, I did not. Okay, it's only about this router and this guy. Fast Ethernet 00. Yes, it's the correct interface. Should reach all of those. So what the trust did, show IP DHCP Snooping. Hmm. Hmm. Could it be that I should trust all of those four? No, this will be no. This will make nonsense. This will make nonsense at all because who grants that all of those are good employees, and who grants that this one is not? I should only trust this one. Okay, what I'm sure about, and or what I'm sure of, is that this router, its configuration is correct because this PC did get an IP of it from it, and this one also is correct because all of those three did get. So I have nothing to configure furthermore in the routers, in the two routers. These two are on the default. We have no problem at all. We have no problem at all. Don't say that I should apply snooping all the way. This is makes no sense because all the interfaces are trusted by default. Like if I said so, show IP DHCP, let's say DHCP please, snooping in here. Yeah, you see, show VLAN brief. VLAN 1 and all the ports are under VLAN 1. I have no problem at all. Just fast forward a bit and try our luck again. It says failed. If I, for some reason, make it a static IP address like .10 and make my gateway .1.1, will I be able to reach the router, or is there anything that's cutting my path? I'm able to. So there is a correct reachability between PC number 1, PC number 0, and this guy over here because I can't ping him or can't ping it. So why the broadcast message is failing? There is a broadcast going to this switch. What will this switch do is that it will not send it to all those interfaces, only to this one. So it will be sent this way, and after that this way, and after that to this one, because I have trusted only the fast Ethernet 06. There is not like show VLAN brief. All of the guys are under VLAN 1 and the snooping is under VLAN 1. Show DHCP snooping. Show IP DHCP snooping binding Okay, and database. Total attempts. Let's read the numbers. Urgent URL. Okay. Agent running. Attempts 7. Success rates 7. I'm only thinking about one thing. Only one thing. Is that I should trust this one. It's not convenient. I'm not convinced at all. But should I trust this one and this one also? This makes no sense. This makes no sense at all. I can do something. What I've did is that, don't get confused, but what I've done is that right now I have connected the router to the same switch, so I will not need to trust those interfaces in here in these switches. Right now the broadcast messages will go to this one, and yes, I should right now trust fast Ethernet 07 that's going to the switch. So interface fast Ethernet 07 IP DHCP snooping trust, and so if the plan succeeded right now, then we have a problem with these two switches and we have to further discover it, and we should. But let's check that again. DHCP, and yes, it seems that it will receive the DHCP because it did not send me any failing message in here. No, it did not. No, it did not. We are still unable to receive any DHCP messages. Yes, request failed. Even though, so it's not about these switches, it's about this one. What do I have missing? Interface fast Ethernet 02. Just 1 minute. All those labels. This is 07. This is 01. This is 02. This is 3 and 4. Okay, don't laugh, but I will do something that I'm not convinced at all. Interface range fast Ethernet 01, 2, 3, and 4. Okay, but I'm not convinced at all. IP DHCP snooping trust. I'm not convinced. I'm not convinced at all. This is not how the snooping should work, because right now only this guy is untrusted, and this makes no sense. Request again. God, it's successful right now. This makes no sense. So I should trust this port and this port so that it will reach. So if we went again back to the same plan, ever interface man, back to the same plan. Let's go back to the old plan that we used. Okay, so he's offering DHCP messages, and this one also is offering DHCP offers. I'm sorry, but request again. It's successful. The other one. Okay, let's see how much successful it is. Will anyone receive from the 10? Now this one is successful also. The third one. Okay, and the final one did also. You see? So now all those four have received DHCP package from the correct router. We eliminated this guy, but this makes no sense. Actually, I'm not convinced with this. If this is how the DHCP snooping works, I will search about this in the networking knowledge. But if this how DHCP snooping works actually, then we need to consider a redesign to the network, because we need to put this switch maybe in a closet and make the suspected one another switch. You see what I mean? What I mean is that maybe this guy, maybe this hacker should have been connected himself to this switch. So at least in this switch I can trust only the network path, and any other devices that connects all of them are untrusted, and that's it. But for the department switch what I work with in, all of the interfaces must be trusted. Actually, this is not something correct, because I have studied DHCP snooping and it says that the DHCP interface trust is to trust, or is to make the interface accepts or receives broadcast, not to forwards broadcast. Those four interfaces, when I trusted them, the DHCP snooping worked correctly, but those four interfaces, they do not receive broadcast. They only send. I'm sorry, they do not send broadcast. They only receive. Oh yes, I'm sorry. No, it's correct. This interface is receiving broadcast from my computer, and this one is receiving broadcast from this interface, so it's this way. Yes, so we need to consider the redesign, and by redesign I mean like having a switch, and this guy should be connected to him in here. This is a redesign, like this one, this switch. This is a suspected switch that anyone can connect to, and I'm not sure who connect to, so I can make this main port is untrusted and all of those other ports are trusted. This is annoying actually. I will further research for DHCP snooping and see if there is any other method to even further manipulate the network. I will post it in a separated video, and I will add the video link in the description of this one in the future, in the upcoming days. So this is how to implement DHCP snooping, it seems, and that's it. That's all what we need to do. We have eliminated this guy from sending us anything, but just in case anyone in the future did connect to these interfaces in here, they will receive from him. So yes, this is about a redesigning. So we need to be careful when we design our networks and how to place the devices and how to connect them. Okay, so this is the end of DHCP snooping video. Yes, we have wasted some time maybe, but it's for troubleshooting, so that I do waste some time for finding some solutions and you don't, because you will find them directly, and when you configure them in the future you will avoid the mistakes that I have done. So I hope that this was beneficial and useful to you, and thank you for watching. I hope to see you in the upcoming video. Goodbye.